These are the answers for the study guide for Chapter 2, Section 5 and Chapter 2, Section 6. So let's take a look at our first problem here. And it asks us which parallelogram is similar to the parallelogram A. Explain exactly how you know. Your reasoning is what they want to know. So let's take a look at parallelogram A. And I'm going to take a look at the side lengths. I see that 8 and 12 are the two side lengths here. And so I'm going to set up a ratio of corresponding sides. So I see that 4 in parallelogram B corresponds to 8 because you look at the different angle markings they have, and that shows it. See the 1 mark and the 2 marks. So we'll put 4 on top, and 6 corresponds with the 12. And so when I go ahead and do some reducing, taking out common factors, I could, actually I'll go ahead and cross multiply in this case, but I could end up reducing the fractions to see what those end up making. And maybe that would be a good way to do it for now, so we can see what we end up getting, and then I'll go over the other way as well. So I'll divide by 4, and I end up getting 2/3. So I divided the 12 by 4 as well. And over here I do the same thing. I take out the common factor of 2, and I end up getting 2/3. So I see that B is the one that is going to end up being similar to A, but let's check this next one out as well. So we have to prove that, and the way we'll do that is the same sort of way. So 8 is to 12 as 6 is to 12. And so you see how 8 corresponds to 6, 12 corresponds to this 12. And so we already saw that this reduced to 2/3, and this ends up reducing to 1/2. And so these are not the same fractions. So I definitely see how parallelogram C is not going to end up being similar to parallelogram A because the corresponding sides are not proportional. So that's what we need to end up saying. So we're going to say parallelogram B, so it looks like they gave us the answer here. And so parallelogram B and A are similar, and the reason is this, because we have to give the reasoning. So we're going to say because, this is where the credit comes into play here, because the corresponding sides are proportional. And so that's our phrase that we need to use to determine or to prove that we've got shapes that are similar. Let's take a look at the next one. It says that the figures are similar. Find the side length DF. So this is DF right here. I'm going to put like a little X to represent that length there. And I'll go ahead and set up my proportion. So I'm going to do 3 is to 9. So I did the short length here to the longer length. So it looks like the short length is 7 in this case, and I see that because of the symbols they're giving me. So you see how the right angle symbol is here, and this marking is here, this 18-degree marking. And so X and 9 go together. So I'm going to end up setting this up as 7 is to X. So I go ahead and cross multiply here. So 3 times X, and I cross multiply here, I end up with 7 times by 9. And so when I do the division, I could go ahead and multiply these right now, but you see if I go ahead and just do the division here, I see 3 is a factor of 9. So I could take out that common factor of 3 and then multiply across, and I'm getting 21 as the answer there. So 21 meters. Let's put those units in there to make sure we understand what that represents. And on this one it says the Mexican flag is 63 inches long. So that's going to be a key word there, long, because I need to set up ratios that are similar, and if I want to make sure I get the numbers in the right spot. So 36 inches wide. So I'm going to look at that wide right there as a key phrase. And so I'll set that fraction up. 63 is to 36. So there is a common factor in there I will take out in just a moment, but I'll set up the next fraction. So it says a drawing of the flag is X inches wide. Okay, see, wide was the 36. So I'm going to put the X along with the 36 because those were both wide. And then 7 inches long. So 7 and 63 correspond. So as I said before, there's a common factor. I could reduce this fraction. It'll make it easier. You cannot cross cancel because it's a proportion, but you can take out a common factor in a fraction. So I'm going to divide this by 9 and divide this number by 9. And when I do that, I get 7/4, and that makes it a lot easier. And so actually I see what x is going to be. It's going to be 4. And you can see it once I go ahead and do that cross multiplying. 7x equals 7 times 4. And I'll do that same trick. I'll just divide by 7, and so I can just cancel out those 7s without having to multiply the 7 and the 4. And so x is 4. So 4 inches is the answer. And then it says the ratio of flag to drawing. So they just said ratio of flag to drawing. So they didn't say area, they didn't say anything. So I'm just going to say that this, because they didn't say the ratio of areas, they just said the ratio, I'm just going to write this as 7 over 4. So flag to drawing. And so notice that I put the 7 on top, 4 on the bottom, because the 7 was the flag and the 4 was the drawing. Whenever they say flag to drawing, that means that this flag needs to be on top, the drawing needs to be on the bottom. Let's take a look at the next problem we see. And it says that the figures are similar. Find the ratio of small to large. Small to large. Okay, small to large would be 3 over 8. That is the ratio of small to large. So you just put whatever comes first in this little phrase here on top, whatever comes second on the bottom. So what they're asking is, you want to know the ratio of perimeters. Well, that is the ratio of perimeters. So ratio of perimeters equals the ratio of sides. And that was a key concept in this chapter here, 2.6, or section 6 of chapter 2. So we'll say the ratio of perimeters is 3 to 8. And then they want the ratio of areas. Well, the ratio of areas is going to end up just being the ratio of the perimeter squared. And so you just take that answer and you square it. And when we do that, we're just multiplying the ratio of the perimeters or sides, whichever one we want to think of it as, and we multiply it by itself. So 9 over 64 is the answer for the ratio of areas. So here we get to use that concept with this problem. It says the figures are similar. The ratio of perimeters is 8 to 3. So 8 to 3. So we've got 8, 3 first. So let me go ahead and rewrite that. It doesn't really matter. I could write 3 to 8 as long as I'm consistent. So 8 to 3. Now 8's the bigger number, so I'm going to go with the bigger figure, 16. And x is the smaller figure, so 3 is the smaller number, so I put x there. And then I just cross multiply. 8x equals 3 times 16. Again, notice I didn't multiply the 3 and the 16 because I see a common factor. I see 8 goes into 16 2 times. That allows me to multiply the 3 and the 2 together and get 6. So 6 inches. That is the value of x. And then they say, what is the ratio of areas? Well, the ratio of areas is 8 to 3 squared. And so it's going to be 64 over 9. So let's take a look at the next one. The ratio of the side length of square A to the side length of square B is 4 to 9. Okay, so that's just the ratio of perimeters there, or ratio of sides. This is A to B. So this is A on top, B on the bottom. And so then it says the perimeter of B is 108. Okay, so let's put 108 on the bottom because it's the perimeter of B. And so we've got to, they want to know what is the area of square A. Well, okay, so we're trying to, this is a square, so if I find the perimeter, don't know what the perimeter is, and actually maybe instead of x, I'm going to use P for perimeter there. So let me go ahead and write a P in there, and I'll go ahead and cross multiply. So 4 times by 108 equals 9p. So I'm going to divide by 9. Now I see 9 goes into one of these numbers. It doesn't go into 4, it goes into 108. It goes into 108 12 times. So I can multiply across, and that gives me 48 equals the perimeter of square A. And so from there, what I need to do is I need to find out what the length of the side is, because what I've got is I've got a square here, and I've got that the perimeter of that square equals 48. So if I divide that 48 by 4, because there's 4 sides there, that's going to give me 12. So that means this is 12 units. 12 units, 12 units, 12 units. So they want to know the area of square A. Well, all I have to do is just do 12 times by 12, and that gives me 144 yards. yards squared is what we end up getting there. So let's take a look at another problem, and it was solve the equation. And so let's take a look at using that distributive property. So I end up with 8k minus 2 equals 3k plus 6. So I've got to use that distributive property first and then just get the k's over to one side. So I'll subtract the 3k from all sides. Leaves me with 5k minus 2 equals 6. So I'll go ahead and add the 2 to all sides, and that gives me 5k equals 8. Divide by 5, and that's as far as I can take it. It's 8/5. I could also write that as 1 3/5 or 1.6. All good answers. So this next one, we distribute first. So I get 42v plus 42 equals, and then the same thing on this side. I get 42v plus 42. So I go ahead and solve by just doing opposite operations. I'll get the v's over to one side, but something happens here. You see those v's all cancel out and make 0. And I'm just left with two numbers, and they equal one another. So when I have this, they call that an identity. An identity means that we have the values of v, because they say solve. The values of v would be infinite. There could be infinitely many solutions. And so that's what we end up coming up with when we're talking about solving, and we end up canceling out the variables, but the numbers equal. We have ourselves an identity. So on this next one, I'll collect like terms here. I end up with 6c minus 8/3. And on this other side, I collect these two terms. Again, look at the signs in front. So that's what I was doing here. 10 minus 4 made 6c. Here, they're both positive. 2 and 4 ends up giving me 6c. And then minus 9. So when I go ahead and solve this one, I've got to move the c's over to one side, and look, they cancel out again. So whenever you have the same variable term on both sides, they're the same sign as well, they're going to cancel each other out. And I'm left with two numbers, and this time they do not equal. So when they do not equal, that means we have no solution. So those are the three types of answers we can have when we're solving an equation. We can have no solution, we could have infinitely many solutions, or we could have a one-number answer, just like we have over here. So those are the problems for this week's test. Good luck.